Expanded notation is decomposing a number into its place. So if I was to look at 357, I would simply write it as 350 plus 7. 142 would be 100 plus 40 plus 2. Now the purpose of this is to do some addition. So we're going to add the numbers in its place. So we're adding the hundreds to the hundreds, the tens to the tens, and the ones to the ones. Now this type of addition is a little bit different than what you might be used to. We're actually going to start and move from our left to our right. And there's a reason why we do this. That's how we actually do algebra. It's actually how you read a textbook or anything else, is from your left to your right. So we're going to do mathematics that way. So I'm first going to add my hundreds. 300 plus 100 is 400. 50 plus 40 is 90. And 7 plus 2 is 9. Now combining these together, I have 499. Now this is not the most efficient way to do a problem. We're going to shortcut it a little bit with this idea of partial sums. Partial sums bridges us to algebra, and you'll see in future lectures on how that works. Once again, I'm going to take my hundreds and add them together, my tens and my ones. So if I add these from left to right, notice I'm saying 300 plus 100, not 3 plus 1. 300 plus 100 is 400, and I actually write the 400. 50 plus 40 is 90. Again, we're saying it by its place value, not its face value. And 7 plus 2, they're in the ones. So I would simply say 7 plus 2 is 9, and the answer to this is 499. Now this is not what we call the shortcut. Obviously, it takes a little bit of space and a little bit more time. But again, it's going to lead us to that idea of algebra and how we add. Let's try one more expanded notation. 571 expanded is 500 plus 70 plus 1. 367 is 300 plus 60 plus 7. We're going to add left to right. We're going to add our hundreds column and get 800. We're going to add our tens column, and you might be thinking, what am I going to do? We'll simply add 70 plus 60 is 130. I leave it in the tens column. That means I have 13 tens. 1 plus 7 is 8. So now we're going to combine these. I'm simply going to add the 800 and the 130. Get 930 plus 8 is 938. How would that look if I did partial sums? Well, once again, I'm going to add left to right. 500 plus 300 is 800. 70 plus 60 is 130. Notice I'm lining up the digits in their place value. 130, the one lines up under the 800. 1 plus 7 is 8. Now to add this, again I go left to right, 938. So notice it matches. It's a little bit shorter than your expanded notation, and partial sums leads us to algebra. So most of the addition we're going to do is through partial sums. Let's perform partial sums on this number here. 700 plus 100 is 800. 30 plus 40 is 70. 9 plus 7 is 16. Gives me 886. Trying it on this three-digit addition problem. 600 plus 400 is 1,000. Notice again, I write down the 1,000 and I move it over 1 to continue to hold its place. 90 plus 60. $90 plus $60 is $150. 5 plus 6 is 11. Adding these up, I get 1,161. So again, we're keeping the digits aligned in their place. This is called partial sums, and it will lead us eventually to addition in algebra.